Hi, I'm Dimitris Haralambidis, and in this presentation we'll learn together how to solve quadratic equations using the discriminant formula. Before we start, we should learn that the general form of a quadratic equation is the form ax squared plus bx plus c equals 0, at which a is different than 0. One way of solving such an equation is by applying the discriminant formula. According to this, we can solve a quadratic equation in 3 simple steps. More precisely, given a quadratic equation, in first step, we start by determining the values of a, b, and c. At this point, you should have in mind that a is always the coefficient of x squared, b is always the coefficient of x, and c is always the constant term, respectively. Moving in step 2, we can use the following formula to find the value of the discriminant d. That is, that d, the discriminant, is equal to b squared minus 4ac. At this point, you should know that if that value, the value of the discriminant, is positive, then we should expect to have 2 distinct solutions. If the value of the discriminant is 0, then we should expect 1 double solution. And finally, if the discriminant gets to be a negative number, then we should have no real solutions. Moving in the third and final step, we can calculate our solutions, if there are any, from the formula which is known as the discriminant formula. That formula implies that the 2 solutions x1 and x2 can be given by minus b plus minus square root of d over 2a. And plus minus here means that at some point we will split that fraction into 2 new ones. At one we'll have the plus, and we will write minus b plus square root of d over 2a, and on the other we'll have the subtraction, and we should write minus b minus square root of d over 2a. Let's now move on some examples. First example, solve x squared minus 5x plus 6 equals 0. We'll solve this example following the steps we mentioned before. So, in the first step, we'll start by determining the values of a, b, and c. Remember that a is always the coefficient of x squared. So, in this case, a is 1. b is always the coefficient of x. So, in our case, b is negative 5. And finally, c is always the constant term. So, here c is 6. In second step, we'll have to find the value of d. We'll do that by plugging the values of a, b, and c in the formula b squared minus 4ac. After some operations, we can come up with the value of d, which will be equal to 1. And finally, in the third step, we'll use the discriminant formula x1.2 equals minus b plus minus square root of d over 2a. We'll plug in the values of b, d, and a into this formula, and we will write minus 5 plus minus square root of 1 over 2 times 1, which is equal to 5 plus minus 1 over 2, and now we'll split this fraction into 2 new ones. The first one would be 5 plus 1 over 2, which is equal to 6 over 2, which is equal to 3. And the second one would be 5 minus 1 this time over 2, which equals 4 over 2, which is equal to 2. So, to answer to our initial question, the solutions in this case for this equation are numbers 3 and 2. Second example, solve 4x squared minus 4x plus 1 equals 0. Once again, in the first step, we'll simply state the values of a, b, and c. Here we have that a is 4, b is -4, and c is 1. In step 2, we'll calculate the discriminant itself. We'll use the formula b squared minus 4ac to do that, and after some operations, we'll end up with the number 0. So, in this example, the discriminant equals 0, and this means that according to the theory we mentioned at the beginning, we expect for this example to have one double solution, which will be obtained by using the discriminant formula in step 3. So in step 3, we will start by writing, of course, the formula. So we would start by writing x1.2 is minus b plus minus square root of d over 2a. Then we would plug in the values of b, d, and a, and we would simply come up with the fraction 4 plus minus 0 over 8. We would have to split this fraction into two new ones, but notice that the result won't change because either we do 4 plus 0 or 4 minus 0, the result in both cases will be 4 over 8, which is equal to 1 over 2. So, to answer to our initial question, the solutions in this example would be, actually is one solution, is 1 over 2. Third example, solve negative 2x squared plus 3x minus 4 equals 0. Again, in step 1, a is negative 2, b is 3, and c is negative 4. In step 2, we need to find the value of the discriminant. By plugging in the values of a, b, and c respectively in the formula that says b squared minus 4ac, and after some operations, we end up with the value of negative 23. So, here, since this value, the value of the discriminant, is negative, we will not have any real solutions. So, the exercise, this example, ends here. For any questions about this presentation, you can always leave comments down below, or you can simply contact me with one of the following ways. As always, thank you for your time.